Now this is something that we went over in class, so we'll go ahead and just circle this one. It says circle the graph that shows constant speed. This is a speed time graph. So constant speed is going to be a straight horizontal line on a speed time graph. This is another one we did in class, so I'll go through it quickly. So the next one says a dog walks for 3 hours and travels 15 kilometers. What is its average speed? So again, speed equals distance over time. So I've got to identify my distance. Kilometers is my distance, so 15 kilometers. Time is 3 hours. So 15 divided by 3 is 5 kilometers per hour. And I can grid that in, making sure I pay attention to my decimal points here. Number 32, a snail crawls onto a ruler and travels this distance in 3 seconds. What is her speed? Measured from the front of the snail, so looks like 2 centimeters. And the front of the snail looks like 8 centimeters. So it goes from 2 to 8. So speed is total distance. So 8 minus 2, that's 6 centimeters in 3 seconds. So 6 centimeters divided by 3 seconds, that's 2 centimeters per second. The number 33, what was Bonnie's speed between point A and point B? Again, this is one we did in class, so we'll go through it real quick. So number 34 here says circle the graph that represents a slow speed, box the graph that represents a fast speed. So again, this is another one that we did in class, so I won't spend too much time on this. So this line is the steepest for Miss Reynolds' class, so that would be the fast speed, and this line is the closest to the to horizontal, so that would be our slow speed. You just have to make sure that these scales are all exactly the same. These scales are all the same, so that means the steeper the line, the faster the speed. Again, one we did in class. So number 36 here, it says write the names of the elements that are in each compound. So we've got sugar here. So we've got C, which is carbon. We have H, which is hydrogen. And we have O, which is oxygen. And we find those by looking at our periodic table. We can find C is carbon, H is hydrogen, O is oxygen. So table salt here we have Na and Cl. So Na is sodium and Cl is chlorine. So vinegar C2H4O2, again we've got carbon, hydrogen, and oxygen. In water, H2O, we have hydrogen and oxygen. So this is again one that we went over in class, so I'm going to speed through this, just give you a couple examples. We'll fill in the blanks here. So some examples of physical properties include number 8, a physical change in a chemical change, a new substance is formed. We did this one just to reiterate that in a chemical change, new substances form. These new substances now have different properties. So chemical changes are changes it says these indicators let you know something. What are 4 indicators of chemical change? So number 44, we're identifying different chemical or physical changes. So grapes rotting, that's a chemical change because a new substance is formed. It's not reversible. Wood burning, we have new substance. That substance is ash. A donut bitten, that is a physical change. It's still a donut. There's no new substances. Clear liquid and red liquid mix to make a pink liquid. This is actually physical change because this is an expected color change. Now, clear liquid and clear liquid mix to make a yellow solid. That's chemical because it's a color change. It's also a solid precipitate forming. Now, water boiling, this is a physical change because that's a change in the state of matter. It's still water. It's just a gas, no longer a liquid. But water with electricity, that's a chemical change. Because what you're doing is you're actually taking the H2O compound and you're splitting it into hydrogen and oxygen gases. You're splitting into hydrogen and oxygen gases. And these are new substances.